Hi, my name is Ajay. Currently, I am pursuing BTech final year in Electronics and Communication Engineering. This presentation is about the project IoT based home automation solutions submitted to Emertxe Information Technologies as a part of internship. Before diving into the presentation, I just want to give a brief introduction about what we will learn so far in this internship. So, let us look. In first week, we learned about C programming. In second week, we learned about project requirements and design Arduino programming. In third week, we learned about building the units peripheral programming. In fourth week, we learned about Disha workshop, which is very useful for our career, and we learned about resume buildings and so far. And this is the simple image about home automation design. Home automation is constructing automation for a domestic, mentioned as a sensible home or smart house. In the IoT home automation ecosystem, you can control your devices like light, fan, TV, etc. A domestic automation system can monitor and or manage home attributes, outdoor lighting, climate, enjoyment systems, and appliances. It is very helpful to control your home devices. It's going to, in addition, incorporates domestic security such as access management and alarm systems. Once it coupled with the internet, domestic gadgets are a very important constituent of the Internet of Things. In this project, we are connecting all the devices under one system, which is able to access all the devices operated from any part of the house. These are the contents: C programming, C++ programming, embedded C programming, embedded systems, project requirements, and conclusion. Okay. C programming is basically used to build softwares like databases, operation systems, and compilers and so on. C program. In C programming, we learned about use of C programming in different fields, and we got information about three levels of programming. Low level programming, also known as assembly, Fortran, Algol. Middle level programming, C, C++. High level programming are Java, Python, C++. Important characteristics of C programming. And keywords and categories. C code contains data representation, number systems, data representation in bit, byte, word, and basic data types like integral, and their example char, int, and floating points like float, double, modifiers, and qualifiers. Conditional constructors: if else if, switch case, for loop, while loop, do while loop, break, continue. And operators, and the operators are arithmetic operators, assignment operators, logical operators, bitwise operators, relational operators, ternary operators. And the arithmetic operators are like addition, subtraction, multiplication, division, modulus, like. And the assignment operators are equal to, greater than, or less than, greater than, equal to, less than, equal to. And logical operators are like and or not, like this. And here we see overflow sign numbers, underflow sign numbers, arrays, pointers, functions, strings, storage classes, preprocessor. And in C++ programming, we are learning about introduction to C++, C++ versus C, concepts of object oriented programming, and the pillars of object programming. And they are abstraction, encapsulation, inheritance, Polymorphism. Polymorphism means and many forms of the operations. Inheritance, deriving properties from parent class by child class, or creating new classes from the existing class. Here existing class means parent class and new class means child class. Encapsulation means wrapping up of whole data and information into a single unit. And C++ features, virtual functions and classes, friend functions and templates functions and classes, standard template libraries. Okay, next. Embedded C programming. No, embedded C is a set of language extensions for the C programming language. Embedded C was most of the syntax and semantics of standard C. Examples: main functions, loops, functions, arrays, and strings. And what is embedded system? An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a larger system. The systems can be programmable or have a fixed functionality. And this is the architecture of embedded system, like sensor, AD converter, analog to digital converter, processor, and ASIC, application specific integrated circuit, D to A converter, digital to analog converter, actuators. Actuators is nothing but controllers which controls input and outputs, and memory which is used to store the information from processor. Okay, next. And A by D converter is used to convert analog signal to digital signal, and D by A converter is used to convert digital signal to analog signal, and sensor we use it to store physical information from surroundings, like that. And next, here we know about hardware. The hardware of embedded systems is based on microprocessor and microcontrollers, software and firmware. Software for embedded systems can vary in complexity. However, industrial grade microcontrollers and embedded IoT systems usually run very simple software that requires little memory. Real-time operating systems, RTOS. These are not always included in embedded systems, especially smaller scale systems. RTOSs define how the system works by supervising the software and setting rules during program execution. And these are the advantages and disadvantages of by embedded systems. And the advantages are easily customizable, low power consumption, and low cost is cost efficiency and enhanced performance. And disadvantages are high development effort and larger time to market. Means it takes larger times to comes to market. And Arduino UNO. The Arduino UNO is an open source microcontroller board based on the microchip Atmega 328P microcontroller, and initially it is released in 2010, and the board is equipped with set of digital and analog input output pins that may be interfaced to various expansion boards and other circuits. Here in the if this is the Arduino UNO image. Here A0, A1, A2, A3, A4, 5 are analog input pins, and the digital pins are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 3. These are and ground. These are the digital pins. And we have power pins like V in voltage, input voltage, ground, and 5 volts, 3 to 3 volts, 3.3 volts, and reset pin, like that. IO reference. Okay. Here we have in middle a transmission TX and RX receiver, like that. And this is about Arduino UNO. And in Arduino UNO we have USB board, USB pin also, and we can use it with, we can share information from this board. That's it.
My name is Y Prithvi. Currently, I am pursuing BTech final year in RGUKT Ongole. Now, I am here to explain briefly about product requirements and software used in IoT-based home automation solutions. Product requirements. It consists of Arduino IDE, Blynk IoT app, Pixim Lab, Null emulator. Blynk IoT application. Created virtual pins. Selected the data streams. Created a template. Added widgets and then data streams to widgets. Interfacing all this using Blynk Cloud. Product requirements. First one, garden lights control. It consists of Arduino UNO, LDR sensor, lights. It takes input from the LDR sensor, gives output as garden lights. Second one, temperature control system. It uses Blynk IoT app, Arduino UNO, CLCD, temperature system. Temperature control system consists of temperature cooling system. It takes input from the temperature sensor and gives output as display temperature on gauge widget, display temperature on CLCD. Second one, cooler control system. It takes input from the button widget, cooler button on Blynk IoT app and gives output as if the button widget is at logic high, turn on the cooler. If the button widget is at logic low, it turn off the cooler. Third one, heater control system. It takes input from the button widget, heater button on Blynk IoT app and gives output as if the button widget is at logic high, turn on the heater. If the button widget is at logic low, turn off the heater. As there is Arduino code to temperature system, it is like here it is we are initializing the temperature system like cooler and heater. These are the output ports, and here we will display right the cooler and heater and keep it as low values. Here the temperature is reading as float values. Here flow temperature to convert this digital values from the ADC to temperature and this degree Celsius. Here our temperature is degrees to is Celsius degree, and here we will the n value read as A0 as analog read and multiply it with the float into 5 and divided by the 1023 and again it's divided and multiplied with 0.01 and we will return the temperature. Here we will use the formula of original temperature in degrees Celsius. Here we will control the cooler and heater values and we will digital write them, and here the values are taken as Boolean values. So this is the Arduino code to stimulate the and we will use the Pixel Lab and stimulate it. For the purpose we are using the Blynk IoT app, which is here. Here see, here the cooler and heater. Cooler is on. And this is the AC, and it is a cooler and which acts as an AC. Maybe it is turning and it is cools down the room temperature. And the less values of temperature is 27.37 degrees Celsius. If we want to heat our room, we will move on the heat button, and heater button has the maximum value of 35 degrees Celsius, and it will get automatically off, and we will get to display value of notification as temperature is above 35 degrees Celsius and turning off the heater. This is the function of CV. The heater button has turned off automatically. So this is the cooler and heater button stimulation.
Hello, this is G. Venkatesh from Rajiv Gandhi University of Knowledge Technologies, pursuing the final year in Electronics and Communication stream. Now I'm going to explain about the serial tank, water tank inlet and outlet value control. In this we have 4 components: Blynk IoT app, Arduino Uno, CLCD and water tank. In the water tank inlet and output values control, we have 4 things to do. The first one is to display the volume of water in the tank. In this we have to take the input as the volume of the water in the tank, and the output we have to display the volume of water on gauge widget and display the volume of water on CLCD. And the second thing we have to do is the inlet value control. In the inlet value control, we have to take the button widgets on Blynk IoT app as input, and we have to give the output as if the button widget is at logic high, turn on the inlet value by sending commands through serial communication. If the button widget is at logic low, turn off the inlet value by sending commands through serial communication. And the third thing is the outlet value control. The button widget on the Blynk IoT, the outlet button is taken as input, and in the output, if the button widget is at logic high, we have to turn on the outlet value by sending commands through serial communication. If the button widget is at logic low, we have to turn off the outlet value by sending commands through the serial communication. The fourth and the final step we're going to do is to control the volume of water in the tank. In the input, we have to read the volume of the water in the tank by sending commands through the serial communication. And we have to give output if the volume of the water in the tank is less than 2000 if it turns on the inlet value and send notification to the Blynk mobile app and display the same on CLCD. This is the serial tank structures like this. So to control this, we will use a Arduino code. The Arduino code for serial tank is here. We use unsigned integer and character values for the volume, and the values to the for the volume we use the character values. This is the initialization here. We use the serial tank begin serial write to know the values of the unsigned into values. Here we will use the loop statements also for the data availabilities in the serial read and serial available will return these value also here. We enable the inlet and outlet values, and this disable the inlet and outlet values also with the help of serial write function. So this is the brief note of Arduino code of serial tank here. So for the simulation, after the Arduino code we will go for the simulation here. This is the tank which is full of water. This blue color indicates the water, and the inlet valve flows which is it have the fixed values will disappear, and again will connect to this with the Blynk IoT app here. See the inlet valve and the outlet one both are off, and the volume is 3000 liters. So here for the outlet valve and the outlet volume is on. So the decreasing of the water is seen here. We are observing the decreasing of water after at a perfect of 2000 liters. The outlet was, you see the volume is 1870 liters, and so the decreasing of volume is automatically stopped. So here the inlet volume is also on water. See the notification is water flow is less than 2000 inlet valve is enabled. So here the 2000 liters of volume outlet value is decreased, then inlet valve is also on. So far for the purpose we have to off the outlet valve and inlet valve. Also again if you on the inlet valve, yeah, here let me, yeah, so this is the purpose of the inlet and outlet valve controlling of the Blynk IoT, and here we display the in the CLCD as here inlet flow is on, inlet flow is off, like that it will be displayed in the CLCD. So this is the full purpose of serial tank applications in the using of the Blynk IoT. And
Okay, now I am going to give conclusion to our project home IoT based home automation solutions. And in this project we simulated IoT based home automation solution with features like automatic garden lights, temperature system and serial tank. We used Blynk IoT application, Arduino IDE, PixSimLab to do this project. CLCD acts as a dashboard. Button widgets and gauge widgets to control and display certain tasks respectively. Thank you for giving this opportunity to participate in IoT internship.